Hello, I'm Mark, and welcome to part 3 of my Unreal Engine tutorials on how to build an asynchronous and data-driven dialogue system for your Unreal Engine games. So let's do a quick little recap of what we've accomplished in parts 1 and 2. So in parts 1, it was all things data structures. So here we went ahead and defined all of the data structures we are going to need to drive dialogue conversations for our orator components in our orator system. Then in part 2, we went ahead and created abstract classes and interfaces that our orator system can house all of the common core logic to help drive our dialogue communications. So here, this is our orator component, and again, I flagged this as abstract. So this component is not going to be visible in the editor. It's purely here for abstract use only. And as you can see, it's got our delegates for communication as well as our delegates for event dispatching. So this is how we're going to hook up between the various entities that wish to communicate. We'll be using these 4 delegates here. And then these 3 delegates are pretty much for event dispatching within the context of the host, which is going to be hosting this orator component. And again, this is abstract, so this is all of the common core functionality that both the AI orator and the player orator are going to use. Then we also created our orator interface, as seen here, and this interface is going to be placed on any actor, character, or pawn class that uses these components. And the idea of this is to create these interface functions that we can then use to help create and manage the communication network for our orator components. And then finally, we went ahead and created this orator-based dialogue widget, which we will then use to help broker communication between the player orator component and the widget blueprint, our dialogue widget blueprint. All right, so that's what we did in parts 1 and 2. So in part 3, part 2 was everything abstract. Then part 3 is going to be everything concrete. So this is where we're going to then create our concrete version of the player orator, a concrete version of our AI orator. And then we'll also go ahead and integrate the player version of the orator component into the player character that Unreal Engine has already created for us in our project. And then we'll go ahead and also create a new AI character that we can go ahead and integrate the AI version of the orator component class into that. All right, so without further ado, we've got a lot of ground to cover in part 3, so let's get started. All right, so to do this, let's go back to the editor real quick. And I'm just going to do a quick little compile to make sure that all of our current code is still good. All right, it's compiled fine. All right, so let's go ahead and create our player component first. So to do that, let's go into the content drawer, go to classes, go to our project folder, and under public, right, what we have right now is we have the orator base, the orator component, and the orator interface. And it's hanging out there, but it's just not seen our data structures as well. So to create a concrete version of the orator component, or a player flavor, I should say, of the orator component, what we need to do is we just need to right-click and go to New Class, and then we need to go to All Classes and find our orator component. And if we go down, it's under here. There's actor component, which is a derivative. So orator is a derivative of actor. There we are. So what we're going to do is we're just going to select the orator component and hit next. And then we're just going to give it a name. So I'm just going to go ahead and just call this player orator component. And make sure that we're going to go into the public folder. So, and then we're just going to say create class, and we'll let Visual Studio and Unreal Engine do their thing in creating a template for us to use off that derivative. All right. Still generating. And it's still going. All right, going into the compile and the final stretches. Gonna wait for it to complete. All right, so let's go back. And I'm just going to say reload all, and that's going to update the solution. All right, so what we have here, so this is our derivative. And as you can see, it's deriving off the orator component. So this is going to be a player version of our orator components. All right, and it's like Visual Studio is still doing some thinking for its intelligence. All right, we'll just go ahead and continue on. All right, so what we need to do here, we don't need to add anything into the includes because the orator component is actually pointing to everything we need here. So let's go ahead and just continue to kind of set this body up first. So the first thing I'm going to do is I'm going to go ahead and create our public, private, public, protected, and public sections. All right. Then in the first public section, I'm just going to go ahead and bring over the default constructor. So there's our default constructor, and we'll get to implement. There shouldn't be. I don't think that there's going to be any implementation in that. We'll just defer any defaults back up to the parent. Next, we're going to need a couple of references. So for players, in order for us to facilitate a communication between another AI, right? We're going to need an interface. So to do that, we're going to use our orator component. And so this is why we created the base dialog up front. So if you want to hook a component or an interface into your component, or even into a player, into another class, and do it from C++, what we need to do is we need to create an edit anywhere property in the blueprints that we can, point a user widget to. Right, and so that's what this is. But what we want to do is when we actually create it, we want to then create the concrete version in C++ to the C++ version that is in our code. And so when we create our dialog widget, we'll be using this base class, but then what we'll do is we'll then cast from here into here, and then that will give us access to any of those public functions so that we can then start manipulating that dialog component from this component. And we'll get to that when we get a little bit further down. Next, as far as properties go, we have an internal property, which is our player response choices. So again, for players, we're going to get a little box which is going to give us some choices. We get to pick one, and then that choice is what we use to then propagate it, continue to push that conversation further and further. Then on the orator dialog widget, and we can bring that up real quick, we have two. We actually have these two multicasts, right? We have the finish and we have the interrupt. And these two need to be connected into our player component. So to do that, we're actually going to create two little functions and make them protected, which is the send selected response and then the listen to speaker interrupt. And because they're going to be attached to delegates, we need to make sure we just have this function here, but we can keep that empty. And as you see, I've got little notes here. Yeah, and this is really there just to remind me that we need this since we're attaching them to delegates. All right, so that will do it for the event wire-ups and for any properties. So now let's just move to our protected functions. So here we've got one virtual override of the cleanup on call end. So if I was to go ahead and bring up the orator components, we have our virtual void here, right? And we actually define some logic in there. So this is the base logic, which both the AIs and the players will need to do. But there's some additional things that the player has to do that the AI doesn't have to do, and maybe some things that the AI can do that the player doesn't have to do. So in order to facilitate some customization there, we made this virtual. And here we're now going to override that virtual component. So virtual void, and then just make sure you've got the override to say that rather than do what's in the base, we're just going to go ahead and do what we're doing here. Use this one instead. All right, so that will do it for our protected functions and properties. So let's go ahead and move into the public functions. So I'm just going to bring them all over real quick. All right, so here I've got a force in line. So this is the current response choice. So when we make a choice selection in the dialog widget, that will come back to the component. And then if I need to use that choice in the blueprint, I can call this get current choice, and that should give me access to this current struct right here. And it's a const, which means it's a one-way. This is a read-only. We can't set it, we can only get. And then we have listen. So again, this is going to be tied into events actually in the player class. So when the player listens, it's going to get the speaking actor. And then we can then do some additional things here. So for us, it's going to be, as a player, we want the actual dialogue lines that the speaker is giving out so that we can see what they're saying. Respond, again, another virtual override. And then we have the initialize dialog widget. So this allows us to initialize our dialog up here so that we have it. And then we also have another virtual override. Should be virtual override. So again, we're overriding nspeak here. All right, so now that we've got this, let's go ahead and just fix the green squigglies. So I'm going to say show potential fixes. Oh, that's interesting. I don't want to add it into there. Let's just go ahead and go straight to the base class, and I'll just copy them over. All right, to do that, let's bring up the player CCP. So I'm just going to go ahead and just bring everything over from here. So first off, I need to solve this. So this is our player orator component. This is the constructor, and we're not going to do anything with the constructor, so we're just going to leave it as is. Next, I'm going to bring over the send selected response. So this is going to be attached to the dialog widget when we go ahead and create it. And so when I click in the widget, when I click a response in the widget, it's going to then fire off the choice back to this component here. And then within this component, the first thing we'll do is we'll go ahead and remove the widget from the viewport, because now we want to, because we're doing something, right? We don't necessarily know what we're going to be doing yet, because we've got to then take that selected response and figure out what we need to do. So here we're going to say selected, we're going to put that choice and hold on to it. So we're going to take that choice and put that into this selected response variable. We're then going to check to see if there's an animation montage on this choice. If there is, then we're going to broadcast the speaker action. If there isn't, then we're going to check to see if there's a sound source. If there is a sound source, we'll do the broadcast speaker action. Otherwise, if we don't have this or this, then it's just straight dialogue. And then so what we'll then do is we'll do an end speaker and then broadcast on speaker action. And the reason why I'm doing it this way is that if there's an animation, what we want to do is we want to kick off the animation first, and then we will then call on speaker end broadcast, right, at the very end. So because we have a dialogue, we can, and it's a choice dialogue, right? I'm selecting something and it's going to fire. then all I'm going to do is I'm just going to do both of these at the same time. But if we have an animation or we have a sound source, we may need to put a wait handle in there. So the animation montage is going to have a wait handle because we want to wait for the animation to finish before we then fire that end speak. With sound, would probably want to use a delay as well. So to delay it out until the sound is finished, and then we'll then fire the end speak. But here we can just go ahead and just do all of this at once. All right, so that's the select response. So next up is going to be listen, speak, interrupt. So this is if I've got the widget up and I want to either skip or abort the conversation, right, with the widget up. So if the widget's up, I have the ability now to then abort or skip it. So what it's going to do, this is just, so we're going to fire it off in the UI. The UI is then through delegation is going to pass that state, whether it be aborted or skipped, to try interrupt skip speaker, and this on the main component is then going to broadcast that out to all of the entities to tell them to either skip the dialogue if they're driving the dialogue or abort the dialogue, okay, because we need to stop this dialogue sequence. So that's how that command is going to be sent from the player. All right, after that, we've got our overridden cleanup on call end. And so this is what we'll be doing in addition to what we're doing in the base class. And that's why I've kind of got this down here. We're going to also widget removal. So we're always going to do a widget removal. And then we're also going to do a on response action broadcast. And again, this is a broadcast back up to us, the player. So this is an internal broadcast back from the component up to the player character, so that if there's any additional things that we want to do in the character, we can do it there. And then we'll do the cleanup on call end. All right, so that will do it for those functions. What's next in the list? All right, so find response is next. So this function is, now we're starting to get into the nitty gritty, and I'm better start getting some includes in here now. So we have the player orator component. I'm also going to need I think I just need these two for now, which is the orator interface and the orator base widget. All right, so okay, so there's a reference to our interface and there's an interface, a reference to our widget. So now we're kind of coming into some of the more, now we're coming into the state machine logic. So find response. So if we, this is to check to see if we have a response. If we, so what we need to do. So the way the system works, whoever is speaking, they're going to do their thing, and then they're going to broadcast out to the whole group a response ID. And then it's up to each individual on how it wants to interpret that response ID. So what we're going to do is first, as always, since we're working with data tables, we want to make sure that that table is connected. So we're going to run the isValid table. Then off that, we're going to say get current topic off that valid table, and we're going to put it in here. And then we're going to say, is the topic and is the topic script table a script table, right? So we're doing a double pointer check. We want to make sure that this topic table is valid and that the topic table has a valid script table attached to it. And what we're doing is we're using a logical AND here. And the way this works in C++ is it first checks this one. If this is valid, then it will go to the second condition. If this fails, it won't even bother checking the second condition because the first condition's already failed on a logical AND. So we're good there. So again, we're doing a double pointer check to make sure that the topic and the script table are both there. If they're both there, then I've got a little bit of a debug here to just say just to make sure I've got the right response ID coming in. And so then what we're going to do is we're going to take this response ID, pass it into the script table, find row, and it's going to pass back a orator play response row if it has that ID. If it doesn't have that ID, this is going to be null. If it does have that ID, it's going to bring back the row. So again, we're going to do another pointer check, pointer validation. Again, whenever you're dealing with pointers, make sure you're making sure that that is a valid pointer. If it's not, and you try and do something with it, the game will crash. And then we're going to say if response. We're going to check to see, is it a stage queue? And if it is a stage queue, right, then do we have at least one response? Because the first response is going to have the animation that we want. And so that's kind of how I pack it, and that's kind of how I decide to package that for the player. So again, these are now going to be the subtle differences, as you'll see, between the player and the AI. So again, if this is a stage queue, we'll go ahead and get the choice, and then we'll go ahead and broadcast that choice to the speaker, right? And this is on speaker action. So again, this is us broadcasting up to ourselves, to the player, to then go ahead and execute the montage if we, that is associated with this response. Otherwise, if not, okay, if it's not a stage queue, then it's considered just some dialogue. So then what we'll do is we'll check the dialogue widget. And then if it's a dialogue widget, then we'll bring in the orator dialogue widget replies and send it the responses that we're going to be using. Okay, so again, on that widget we have a function called replies, and so this is how we're putting it in. And then we execute the on-speak begin, which is going to broadcast out to the rest of the group that I'm the speaker, and that's why we're using get owner there. And that's going to again send the actor out to the rest of the group, and then the rest of the group can do whatever they need to do. If you need to turn them to face me, then that's great, or face the player, then that's great. And then if anything fails, we've got some error messages to figure out why it's failing. All right, so that is find response. So next up is going to be widget removal. So we've seen this function twice. So let's go ahead and bring this in. So this is our widget removal. So it's really what we're not actually deconstructing it, right? Once we initialize it, it's there and it's there to be used. What we're doing here is when we say removal from parent, we're actually just saying take the widget and just so we have, when we want to add a widget to the viewport, we use add to viewport. If we want to remove it, we call remove from parent, and it will remove the widget from the viewport. And so that's what we're doing there. We're just removing that widget from the viewport so that we gain all of that real estate back. All right, next up is listen. So this is what our character is going to do when we listen. So I'm just going to go ahead and just minimize these two real quick. So this is our listen. So again, when one of the entities goes and broadcasts there on speak, we'll get the speaker. And then once we get the speaker, because we have the widget, we will first want to check to make sure that the speaker is valid. It should be valid, but we're going to go ahead and cast it because we need access to the functions on this interface. So we're going to take the speaker, cast it to the orator interface, make sure it's a good cast, and then if it's a good cast, we're going to then check the get current script lines. So again, when we worked on our interface, and I'm just going to bring this up, we have this get current script lines. And so this is really only used for entities, right? So that we can take a look at the dialogue lines that the entities are going to be, going through. So as long as we have some lines, then we'll check one to make sure that this thing's been initialized. Again, we want to make sure that that's valid. And then once it's valid, we're going to call speaker instead. So as you say, so with find responses, we called replies. But when we're listening, we're going to be calling speaker. So this is going to then set the widget to speaker mode versus reply mode. And in doing so, we're going to send the current script lines, and we're also going to send the get character name. So, and again, script lines is on the interface here, and we've also got character name, which is also on the interface as well, and that's right there. All right, and then we'll check to see if if the widget is not in the viewport, right, is in viewport, then we're going to add it to the viewport. Otherwise, if it's already in the viewport, it's already there. We don't need to add it a second time to the viewport. So that's all this is doing. And again, the not symbol. So, which says just if it's in the viewport and not, then it's not in the viewport. So we only want to do that. Otherwise, again, some error messaging here and here just to check to see, if this fails, then we want to tell, in debugging, we'll say, hey, you forgot your widget, or hey, this thing for some reason is not for some magic reason is not using this. It should be at this point, but again, we're just going to do a double check. All right, so that is listen. So next up is respond. So that's another function that we're going to be overriding. So I'm just going to go minimize this. So respond. So here we have our response data. So this is where we start. This is the actual state. This is where we start. This is the state machine, right? So we send, this is when the speaker ends, they're going to send their response. And so everybody's going to listen, and this is where we're going to start processing our response right here. So on the player, when we're listening to the end call, we find the response, and then we're going to do a quick check to look at the state. If it is a continue, so again, we have a not statement here. So if we're not continuing, right, then it means we're ending the conversation for some reason. And it could be that we're ending it because we're getting a quest, we're ending it because we're buying something, trading something, or we're just ending the conversation because we just don't want to talk to them anymore. But for whatever reason, we're ending the conversation. So we just check, we set the state to the current conversation state, and then we call on the parent class, on the base class, end this conversation. Otherwise, if we are continuing, then all we're going to do here is we're going to say conversation state, response state again, and then this is where we'll go and find the response. And this is where we'll check to see if we're the ones actually need to respond to this or not. All right, so that is find response. So next up is going to be initializing the dialog widget. And let's just go ahead and minimize this. So here we have initializing the dialog widget. So this is what you need to do if you're wanting to include a blueprint widget which has a C++ base class and tie that into your component. So as you can see up here, we have two. We have the widget dialog, which is going to be pointing to the widget, the blueprint widget, but what we actually want is the concrete or the base class, which is under the hood. And so to do that, when we run initialize, what we're going to say is we're going to say create widget of this type, which is the base class. And for us, it's going to be the orator-based dialog widget. And then we're going to say, and then it's going to require two parameters. First, it wants the player controller. So we're going to say get first player controller, which is going to be us. And then we want the actual dialog widget. So this is the blueprint version of the dialog widget. So we're going to pass that in, we're going to pass the controller, and then that's going to give us the C++ base that we can then use to help control the widget from C++. All right, so then once we get it, let's check it. So if we accidentally put the wrong widget in here, this will come back null. If we put the right widget in, this will come back as a pointer. So let's validate the pointer, and then after we do that, if it is valid, we're going to go ahead and create our dynamic casting. So this is how you set up your, this is how we go ahead and create those bindings for our delegates. So here, we have the reply finish. So as you can see here, there's a couple of parameters. I'm just going to bring this up. So the first one is going to be so what we want is the user object, and then what we want is the function name. This is the user object where this function name is located. So in C++, we just use the this pointer, and then we use an ampersand and just the name of the function. So on finish reply is going to go to select response, and then on interrupt is going to go to listen speaker interrupt. And here it is important to make sure that the arguments going in are the same. If they're not, you'll get a red squiggly under here saying that there's an issue, and it's usual, and most of the times it's because you don't have what it's receiving set up correctly. So since this is a one parameter, on listen it's taking the enumerator, on this one it's going to be taking the data structure. All right, so, but yeah, that's pretty much it for initializing the widget. So next up, actually the last thing we need to do is the nspeak. So I'm just going to copy this, bring this down. So we have player orator component nspeak, and on nspeak all we're going to do is on response action broadcast. And here again, this is the reason why I'm overriding it, is because selected response choice, response, and response state, this is what we need to then broadcast up to us, and then this is what we need to broadcast out to the rest of the group. And so nspeak is, we're not ending the conversation, all we're doing is we're ending our piece of that conversation, and we're broadcasting the response back out to the rest of the group so that they can keep the conversation going with whoever is intending to keep that conversation going. All right, so that should do it for everything here. So I'm just going to go ahead and save that, come back up to the components. All right, so that should do it for the player component. So next, let's go ahead and build the AI version of the orator components. Okay, so to do that, let's just go ahead and go back to our editor, and just like we did for the player, we're going to come to the content drawer, go to C++ classes, go into the folder, go into public. As you can see, we have our player orator component right here, so we're just going to do the same thing for AI. We're going to come into add class, hit all classes. I'm just going to type and there it is. So what we want is, again, is the orator component. So there's our player component derivative down there, but what we want to go back up to the base class because we want to use that one to derive our AI version. So for that, I like to just keep things a little simple. I'm just going to call it AI orator components. And hit create. So now this is going to be where we're going to create the AI derivative of that orator component. C++, all right, good compile, everything looks good. Come back here if we want and go back to the public, and there it is. There's our new derivative. All right, so let's go ahead and back to C++, and let's reload all real quick. So here we are, our AI component. It's going to be the same deal as the player for the most part. So again, let's go ahead and just create our sections. All right, so let's get started. So again, it's inheriting from the orator component. This is the AI version, which will be used for any entity that is not a player entity. I'm just going to go ahead and give it a default constructor. And let's go straight into protected. So for protected, as far as properties, there are no properties that I wish to surface to the blueprint. This is just for internal use only. So we have the current dialog, and again, it's a null pointer since it's a row reference. And I've got the starting point name. So again, The AIs are usually the ones that are going to be initiating this, so we need to make sure. So this is where I set that starting point, and we'll see that a little bit more when we get to the integration, and then finally when we start getting into, I think, into video 5, where we go to the AIs and start building out the AI blueprint, and then closing the loop on all of this stuff and making it all work. All right, so for functions, very similar. So here we've got cleanup, on-call, override. We also have find response. So this find response is different from the player version of find response. Just going to go do that real quick. This is the AI version of find response. And so this function is in there. We have begin speak. This is actually internal. And then I also have the can start new topic. So again, this is just another function that I've got there just to check to see if this topic and starting points. So 1, check to make sure that the character has this topic, and 2, to make sure starting point is valid too. I'm using this mostly when we get to topic switching. And we'll see that when we get into the implementation. As far as the public section, I'm just going to go ahead and bring this out, and this is going to be a virtual void. Just set that. All right, so here we have virtual void response, so we're overriding the response. We've got set conversations, get current lines, and start conversation. So this is just a function. If this character is doing the speaking, we want to make sure that the player can get the lines. So this is how we're going to get the lines out. And then using the this will pass it through the interface of the entity that has this component, and then back to the player. Back to the player components, I should say. Start conversation. Again, this is useful. This is how we start the conversations, get current dialogue, and then end speak. All right, so that is, again, this is the difference between the standard, or between the player and the AI. So let's go ahead and get the implementation done. So I'm just going to come over to the orator components, and we'll go ahead and we'll just go straight down from top to bottom. So first thing, I'm just going to set up the constructor, and it's just a default empty constructor right now. Nothing really in that. Next is going to be the AI's version of cleanup on call. So again, it's slightly different. We still call the on response action, but instead of broadcast, we're going to broadcast the current conversation state. Again, this is response action. So actions are actions that are going to get bubbled up from the component up to the entity, the owning entity, so that it can then do do whatever it needs to do based on this. We're going to then set the current dialogue to null, and we're going to then run the base class, or the base functionality of cleanup on call end. All right, next is going to be the find response. So here, just like with the player, we're going to get a response ID. A response ID is going to come in. We're going to do a couple of things. We're going to make sure that we have a current topic ID set, so that we can get the current topic that we're all talking about. We're going to again make sure we have 2 valid tables, that the script table is valid and the table pointer is valid. If both are valid, then we'll go ahead and find the orator AI response row, right, and bring that back into the current dialogue here, based on the response ID. So the player table and the orator AI response row and the player response row, right, they are slightly different. So again, we need to handle, we need to check on different tables, and check for those different tables. So again, we're going to bring this back, and if this fails, then we're going to make this null, and if this is null, then we're going to get an error message if this is turned on. Otherwise, if this is not null and this is not null, right, then we'll run begin speak. and we'll get to that a little bit later. Next is begin speak. Well, here it is. So here we are, begin speak. So again, on begin speak, we're going to broadcast the owner, and then we're going to run the speaker actions. So here again, we're going to broadcast out to the group that, hey, I'm speaking because I've got this response is mine, and so we'll broadcast that out, and then we'll say on speaker action broadcast. Just going to get some more real estate back. All right, can start new topics. So since the entities are the ones which actually do the start the new topic, even though I can change the topic or I can tell the entities that we're changing the topic, the entities are the ones which usually are then going to then say, okay, I'm going to switch and I'm going to start a new topic. So we need to figure out which entity, if it's a group of entities, is the one to actually start that. So we're going to put the topic ID in, which is the new topic ID, and then we're going to check the starting point. And so we want to see if this entity can start the new topic. If they can, we'll return true, and we'll set the row. So we're going to do a row check. We're also going to do a lines check. So if they've got row and lines, we set to true. Otherwise, if they don't, we'll set it to false, and this entity is not going to be the one to start that new conversation. All right. So that's that. So now we're going to get back into the response for the AI. So this is the AI response, and this is a little bit more involved than the player response. So here we have respond, orator response data. So here's the response coming in. Again, this is the state machine in action. So the response comes in, we check to see if it's not continue. If it is continue, we just come down to here, make that change, call find response, and see if we're the one, which then comes back up to here and checks to see if we're the one that is going to be responding. If we're not responding, then we're just listening in. Otherwise, if we are responding, we will start the conversation or start the next part of the conversation. Otherwise, if we're not, we're going to check to see if we're starting a new topic. If we are starting a new topic, this is where we're going to say can start new topic. Then if it's a new topic switch or a topic change, then we're going to say, is this the entity that's going to initiate it? If they are, right, so if this comes back true, then we're going to set the topic ID, new topic ID to new topic ID, starting point to response ID, set the current conversation to new topic, and then we'll run end this conversation right here. And then this is going to then broadcast out to everybody to say, we're ending this conversation and because it's a new topic, and then this entity will then start to create, will then initialize, and in that end, everyone's communication networks gets dismantled, and then this entity will then tell everybody who is, who wants to be a part of this topic to bring back up a new network, so that they can then continue the dialogue with this new topic. And so that's what's going to happen there. And then if this is not a new topic, then this is an exit. So instead of exit new topic, we're going to exit the conversation. And so this is where we'll be exiting out. So again, current conversation state, response state, and then we'll just say end this conversation here. So slight difference based on whether it's new or ending. Only because there's some additional things we need to do. All right, so that's the state machine on the response. All right, so next, let's go ahead and go to set conversation. So here, this is a function that gets done up, I think, in the integration with the AI and the component. So this is how we start. So again, here's our starting point. We're just going to say set conversation there. Next, we've got end speak, so on response action broadcast. So again, this is different because we've got this current dialog, which is a pointer to the dialog response and response state. So this is just the AI finds this information slightly different than the player does. So that's why we've got our end speak and we've virtually overridden it. Broadcast current dialog, dialog name and response. Again, this is just coming off a table pointer. So since it's a pointer, we're using a pointer. But then this is a struct, so we can use a .concatenator there. We also have the get current lines, which is, again, we'll see this as we start wiring things up a bit more on how these lines go from the orator that is speaking to the dialog widget through the player orator. But this is getting the current lines, dialog, dialog lines. Otherwise, if it's not otherwise, if this is null, we're going to put this back. So again, we're always going to return something. We're either going to return an array of blank ftext, which would be 0. Otherwise, so we're going to return an empty array. Otherwise, we'll return all of the lines which are associated with this piece of the dialog. And then finally, we've got start conversation. So this is the thing that starts the state machine. So start conversation. Again, make sure our tables are valid. I've got some error messaging here if you want to turn it on. And then we have find response, and there's the starting point. So there it is. All right, so I think that should do it for our AI. Let me just quickly double check, make sure I haven't missed anything. Come over to the AI component. All right, all the green squigglies are gone. That's usually a good sign. All right. So now that we've got our two concrete classes, let's go ahead and move over to the entities, the host entities, and get them set up so that they can host these components. All right, and so let's do that. Okay, so when Unreal Engine went ahead and created our project, they were nice enough to create a character class for us. So we're going to go ahead and use that character class. So I'm just going to go ahead and close the orator components. I'm just going to do a quick little compile to make sure everything is still good as far as the compiler test. Yep, good. And I'm going to come back to the solution and let's go ahead and open up the core. Mine's called Core Orator Live Character, and it should be under the main solution. So when I click on that, as you can see, we've got this abstract here, which is again, just Unreal Engine saying that you can't create a concrete off it. You can't use it as a concrete, but you can certainly tie it to this to a blueprint. So here's our class, right? And this is everything that they created for us. So as you can see, we've got a jump, move, look, and mouse look actions. Camera, boom, follow camera. We've got the setups, we've got the move. So everything that you would see if you did this just with blueprints, all they've done is they've just recreated this in C++ for us so that we can then build on it. And they've got some pretty nice notes in here too to kind of explain what's going on. All right, so let's go ahead and integrate our component into this. So first thing we're going to do is we're going to make some little changes up here. So I'm going to create the orator interface. So this is going to be the interface that we're going to use to get to our that's going to allow us to connect any entities that want to use our orator component. So there's our interface right there. Say little squiggly. Let's see. Maybe I can. Public. All right, got one extra thing in there. So here it is, public orator interface. Okay, so when you want to attach an interface to a C++ object, all we need to do, if you haven't done it already, all we need to do is we just need to come down to the class here, and at the end of the character, this is where we can now start to add additional things to it. So I'm going to put a comma, and I usually like to just put a space to put it on the second line. So I'm going to say public orator interface, and that's all you need to do. And you can have as many interfaces on here as you want. That's why I usually kind of move it down to the second line. So this is pretty much saying that this class is inheriting from this class. Now in C++, technically, you can have, supports multiple inheritance of classes, but like any other object orientation program, it also supports multiple inheritance of interfaces as well. So you can have as many interfaces on here as you need to support your coding. All right, the other thing I'm going to do, just to kind of keep this in line with how this code is set up, is I'm going to go ahead and under classes, I'm going to add the uPlayer orator component. So this is just a pre-definition. And so again, this goes out to the linker, and when the linker says, rather than flag it as a linker issue, it's going to say, I'm going to wait until I've fully compiled, because there's a good chance that the definition is going to be pulled in a little bit later. So that's why we're doing that there. All right, next, need to just go down, make sure we don't miss anything. So what we've got here is we've got the spring arm component, and we've got the follow cam. I'm going to go ahead and add my component here under protected. So here, this is our player orator component pointer, and I'm just going to call it player orator. Again, property, visible anywhere, blueprint read only, and I've given it the player character components. So again, using the pipe to kind of create that second layer under player. All right, and then I'm also going to create, since we like to have names, I'm going to put the player name here as well. And that's under player, and I'm just going to put it under data. All right, so that's the component, and that's the player name. So that's the only things we need to do here, but we have this interface that we want to go ahead and do. Actually, I am going to do a couple of other things. So let's see. I'm actually going to put a begin play, and I'm also going to put an end play. Don't need it for. I probably don't need the end play for this player yet, but I like to include end play. So begin play, I think most of us are kind of familiar with, right? And this is kind of like, when we begin play on wire up. Right, at runtime, we want to then instantiate a bunch of additional things, but we want to do this at runtime, not at compile time. And again, end play is very similar. End play, if you think of begin play as your runtime constructor, end play is kind of your runtime deconstructor. So if you need to clean things up before a actor, a pawn, or a character gets disposed, you can run end play, and end play will allow you to clean it up before it flags it for the Unreal Engine garbage collector to finalize the disposal. All right, so I'm just going to include those for now, in case I need it. Move, don't need that, don't need that. So as you can see, force inline. All right, so I'm just going to go ahead and just bring all of these over. So the only things we need to do is we just need to bring in all of our interfaces, and I also on the player have an additional function here, which is also going to be bound to a delegate too. All right, so this is everything in our interface. So when you're using an interface, you need to make sure that we implement all of the functions on the interface within the class that is using it. So then that's kind of why I brought everything down here. So now that we've got this, let's go ahead and I'm just going to go ahead and fix the green squigglies, and we can move straight into the implementation. All right. It's a little bit fiddly. And 3 more. And 1 more. Okie dokie. All right, so that is the implementation. I'm just going to go ahead and just bring these back for formatting. Okie doke. So as you can see, these functions here are going to be bound to our events. So again, this is all of our networked communication events. And then we also have this one here. This is going to be bound to an action on the component as well. And this is our listen to, orator, end action. And the reason why I've got this outside of the interface is because this is unique to the player. And this is just an action where this is everything that is in common with it. And the reason why I put this in the interface is because we're going to be looking for these same functions on the other side when we do our event wire up. So it just made things a lot easier. So now we're going to go to the implementation. Let's go ahead and set this up. All right, so first off, I'm going to come to the constructor. So because we've got our new component, we need to be able to add it. And I'm also in the constructor, I also need to add the delegate as well, or bind to that delegate. So to do that, I'm just going to come up here. So here we are, we have our player, orator, conversation end, dynamic, and I'm just going to go ahead. There it is. Let's just finish that. And as you can see here, I've got a red squiggly, so it means I need an include, and I'm going to put that up here. I'm actually going to bring in 2 includes. So I'm bringing it, so this is the include for our orator. So again, this is our player component. This is where our player component is located. But I'm also going to bring in this Kismet Systems library, and I'm going to use this for our spherical sweep, only because in order to do it, there's a lot of additional things that it does, and I just want to keep things nice and neat. This library is the same library that the blueprint uses, so if you wanted to, you could use this for all. It supports all of the same tracing tools that you find in the blueprint, so and again, it just depends on how you want to use it. For me, if I'm just using simple line tracing, I'll probably just use it straight off the get world. But if I'm doing something which has some additional things on top of it, like a spherical trace, sometimes it's just better to use this since it's fully tested. So again, this is under Kismet Systems Library.h. So we'll be pulling that in. But that should satisfy this. So what we're done here, so we're using the create default sub object, and we use this when we're doing in the constructor. So what we want is, so when the editor goes and brings this in, right, it's going to go ahead and runs the constructor for that object, so we can see this thing. And we're also just going to create the dynamic binding right here too, and it's going to be bound to our listen to orator end action, and that's on conversation end action here. So we're just going to go ahead and create that binding, and I'm just using a text. So the way, again, this is just how you create that object. So it's going to create the object, add it into Unreal Engine's memory manager, and then pass back the pointer. And then from there, we're just going to go ahead and build this out. Okie dokie, and as you can see, it's doing the same thing for everything else. If you wanted to then create an object at runtime, instead of using create default sub object, you just use new. I think it's like new sub object, and it does the same thing, but it's used, that one's used for runtime, this one's used for compile time. It's the only difference. We don't need to do anything on player inputs, movements, and so I'm just going to go ahead and minimize this. All right, so next, the only other thing we need to do now is come down to our base component for our interfaces, and let's start filling this in. So what we have here is we have a get orator base component, and what this is going to do is it's going to return this is a constant, so it's a get only. So this allows us to pass back the reference to a pointer, right, without exposing that pointer, so it can be changed outside. So that's why we need to make this a constant, and this is a get. So this is a get only. So that's the player orator. And as you can see, it's going to be passed back by its base. And the reason why we're going to do this, I'm going to start showing you in the join conversation. So join conversation number one, this is our peer-to-peer, and so it's going to take a topic and a target. The target is what the entity is going to be looking at, and the topic is the topic that it wants to talk to that entity with. So to do that, I'm just going to go ahead and bring all of this over real quick. Okay, so to join into a peer conversation, I'm just going to bring the code over. This is what we're going to be doing, and as you can see, let's just go ahead and just fix this real quick. So it's pointing to the right functions. All right, so what we have here, so for peer-to-peer, again, topic ID and target comes in. So because we're going to be using recursion, we need to put a blocker in here. So that's what this is in conversation is purely. It's there to prevent us getting into a recursive loop or an indefinite recursive loop. So what's going to happen is either player's going to be asked to join a conversation, and the conversation, if the player, as long as the player is not in a conversation, it will then check to make sure that it has access to the topic. If it does, then what we're going to do is we're going to go ahead and cast to the target interface, which is, this is the target coming in, and we're going to then say, okay, let's go ahead and create our orator interfaces. So this is usually a peer-to-peer, and so usually the person calling this is going to be the entity that wants to create a conversation. So it's like, I found somebody that I want to talk to, or maybe have some way of flagging them down. So check to make sure that they're not in a conversation. If they're not in a conversation, check to see if they are interested in the topic that I have to talk about, and if they are, check to make sure that they have the orator interface. If they do and everything looks good, then as the player, I'm going to initialize my dialog widget on the orator. So we're going to do we're just going to do a dialog initialization to make sure everything's good to go, and then we're going to go ahead and this player is going to add itself to the topic of conversation. And then what we're going to do is we're going to go ahead and create binding. We're going to bind ourselves to the target so that we can create our connection, our communication connections with the target, right? And then the target's going to then what we're going to then do is we're going to tell the target to do the same thing to us, right? And then the target will then do the same code, and then it will then call join conversation again. But because I'm already in a conversation, we've terminated the loop. So, and that's why this is how this is working. So we're going to be using recursion between multiple entities in order to create our bindings and join a conversation. And again, this is on speak. So this is going to go to listen, which is down here. We got listen to orator end. End our conversation, and then we have the listen to the interrupt. And these are the four that we need in order to manage broker that communication between all interested parties. And this is really creating a multi-point to multi-point communication network between all of the entities. Actually, this one is actually just a point-to-point, since it's only going to be between two. The join group conversation is actually going to be the one where we can create a multi-point to multi-point communication. And it works similar to the way that the group works, but with a few differences. So I'm just going to go bring that code over. All right, so this is going to be, again, this is our peer-to-peer. This is two people having a conversation only. This is going to be used for a group conversation, which can be this is a multi-point to multi-point. So again, very similar to the peer-to-peer. I'm just going to go ahead and just start minimizing some of this. Again, if this player is not in a conversation, then then okay, take it to the next step. Is this player, does this player orator have, is this player orator interested in the topic of conversation? If it is, then again, the player is going to initialize. So as you can see here, I have this commented out because I wrote this to work with my interaction system and my camera base. And so one of the things I found when I was building this, that I needed a way to suspend the interaction system because I had a widget UI component in there which I didn't want to fire. So what I do was I just suspended it when we're in this conversation, and then I just restarted it again once we're out of the conversation. So I've got that commented out, but that's where I would put the suspension if you needed to suspend yours for whatever reason. And then here we just add ourselves to the conversation. So we just pass the topic ID in, and then as soon as we call add to conversation, we're going to then close this off. So this goes from false to true. So we're now in a conversation. So if anything else calls in, it's just going to kill it right there. And then we need to go ahead and create our multi-point network. So to do that, we're going to be using the Kismet library, the Kismet systems library, sphere overlap actors. And in order to set that up, we need a starting location. So that's just going to be the starting actor location. So I'm just going to use that. Keep it simple. We're going to need, because we're doing an overlap of multiple actors, we're going to need a actor array here, right? So this is going to, actually this is the ignore array. This is the actor array down here. So this is the output, but we need to have an array of actors that we want to ignore. And the only thing that I want to ignore is myself. So this is this pointer to the character. We're going to add that in. So when it does its cast, it's going to ignore itself and only get those that are relevant back. We need to know what type of query we want to do. So to do that, we have object types here, and then on object types, we're going to set this to world dynamic. So I'm only interested in any dynamic objects. So that should cover pawns and characters. Now, if you wanted an actor to have this, then again, you'd probably want to make that world dynamic. Make that actor, if it's a static, make it a dynamic, and it should then be carried out into this system. Otherwise, if you don't want to do it that way, you could just come in here and change this so it would include everything, both static and dynamic. And to do that, you just say add world dynamic, and then you just do another add for static. But again, by doing that, you're just including more stuff into this output array that you then have to iterate through. So I'm just going to keep that small. Again, the ignore list, and then once we have that and the output, then all we do is we just set it up. So again, we need this pointer to the world, we need the start location, which is our get actor location up there. We need the radius of the sphere, and that's coming from the player orator, and this is in the topic radius. So that's what we've done, and that's why I've got that value there. So I can adjust this based on the topic. Here's the types. So again, this is everything that we want it to catch. And then this is the class that we want to catch. So I've made it very generic. I'm just saying an actor. But if you only want to use this for characters, then all you would do is you just move that up to character. But if you want pawns and characters, then you just use pawn, and that would include pawns and character classes. But I'm going to include all three, so I'm just going to go take it down all the way to the base, which is the actor. Our ignore parameter is right here, so this is everything that we want to ignore. We just want to ignore ourselves. And then this is the output, which we're then going to process. I have a debugger, so if debug is turned on in the component, then we'll just draw a sphere here. So I have draw debug sphere, again, get world start, radius, how many line sections you want, and then the color. For players, I'm going to use green. I think for AIs, I'm using magenta. And then, does it persist? No, I just want it to last for 1 second and then go away. All right, so from here, let's go ahead and just fix that real quick. So just like with the peer-to-peer, I'm just going to change the class for the function. So this is core Oracle live character, and then these are the functions that we're binding to. So here's a little bit different because we're bringing back an array of actors, of possible actors, right, that could fit the mold. We're going to iterate through each one of these actors, and we're going to go ahead and cast it to our interface. If that actor has this interface on it, then we're going to go ahead and bind to it, right? And then we're going to tell this, and then we're going to tell that to go ahead and join the conversation. So this is just going to go ahead and iterate through, and then we're going to tell it, here's the ID, go ahead and join the conversation. So I'm binding to it, but it doesn't necessarily have to bind to me. But again, this is a recursive loop. We should sweep everything up, catch everything, and then see if we can create those conversation networks. And then on the if count, player or in, so here we've got a little bit of a catch-all. So if this is 0, we go through all of these orator interfaces, we go through all of these actors, but none of these actors have this interface, then we're just going to go ahead and tell this to end the conversation, because we're trying to start a conversation with ourselves and no other participants. So we have a little bit of a catch-all there. All right, so I'm just going to minimize that. So next up is listen to the orator begin. So in the context of the player, so we're going to take the speaker coming in. So what I'm going to do is first I'm going to check to make sure this is a valid pointer. If this is a valid pointer, then I'm going to pass that pointer into the listen. And that's all I'm doing there. And here, this is on the response. So again, this is listening to on the end. So this is the begin. So when someone starts speaking, they're going to send the speaker, and then once they're done speaking, they're going to then send the response ID to take it to push the conversation forward. And so the orator is then going to take that data and then pass that into the class on respond. So again, this is the state, getting the next element in the state machine. End conversation. So if end conversation gets called, we're gonna call remove from conversation, which then tells our player to go ahead and do all the cleanup that we need to do. We have listen to interrupt. So if for any reason there is an interrupt being called that isn't us, so if one of the AIs has decided to say, no, we need to stop this conversation because we've got to deal with something, then they can go ahead and they're going to run the abort. We're going to listen to it. Then we just set our flag, and then we go through our process. So we'll say get the interrupt state. If it's an abort, then we're going to go ahead and abort. If for some reason they send a skip by accident, we will ignore it because it was an accident. It's only on abort that we actually care about interrupting the conversation, the player conversation. As far as the get current lines, we don't need to return anything to an AI or an AI entity, so we're just going to keep that blank. As far as the name, yeah, we could maybe want to pass that back, so I'm just going to put that in. That's the player name. And then finally, I'm not going to add anything in here, but if you're using an if you were to use, say, a camera-based interaction system very similar to mine, and you needed to suspend it, then we need to start it back up again once everything is ended. So that's where I would do that. So I'm just going to keep that commented. And if you're interested in a camera-based system, then I can leave a link in the description below on where that to something that I created. It doesn't necessarily have this function yet. in that version, but you can probably just easily add that in on how to suspend and restart it. Should just be one line of code. All right, so that should do it for integrating our player in. So next, let's go ahead and create a AI character, and we'll go ahead and tie our AI code into it. So I'm just going to go. All right, so let's do a quick little compile. Make sure everything's good. Oop, we got a little error. What is this error? We did an override on begin play and end play, and we didn't do the implementation. So we have an unresolved linker. So let's go ahead and just fix that real quick. So I'm just going to come back. Let's go to character live. And all right, so begin play, end play, it's set to override. Because it didn't give me green squigglies, I didn't add them. So I'm just going to go over here and we'll take care of that real quick. I added this under here, so I'm just going to add this here real quick and set these to the functions. As you see, so one of the things if you're using end play and you need to do any cleanup, make sure you do your cleanup before you call the super. Otherwise, if you call the super first before you do your stuff, then whatever you need to clean up will not get cleaned. So do your stuff first, then call this. Begin play, usually we call begin play first and then execute our stuff. So end play is kind of like the reverse. So I'm just going to leave that. But for this tutorial, we're not going to be doing anything in end play. So I'm just going to leave that, or begin play. So we'll just leave those empty. But I like to have those there in my class. All right, so let's go ahead back to here and try this again. So compile. All right, good compile. All right, so now let's go ahead and create that AI character. So, oops, no, let's stay in the editor. Let's come back up here. I'm going to go to classes, core. I'm going to go ahead and just add it straight into here since it's part of this solution. You could go ahead under public and create some subfolders, or you could go ahead and add it here, but I kind of like the public-private structure, so I'm going to add it here. So new character, and I'm going to hit next. And for this, I'm just going to call it demo AI character. Keep it simple. Again, public-private, and I'm going to hit create. Let it compile. All right, so we should now have our new character class. So here we are, reload, and then let's see, there it is, right here. So again, if you're just creating a new character from scratch, this is pretty much everything we need. So let's go ahead and start setting this one up. So again, just like we did for the player, we need to add our interface. So I'm going to bring this in, and I don't have a subfolder, so I'm just going to do that. All right, so there's our interface. So now we just need to add the interface so that we know that this there it is. IORTA interface. So this is a character, so when we cast it, it should be valid because it's now got this interface on there. Under protected, I'm going to add 3 things. Right, so I've got the orator component here, and since this is the AI orator, I'm just going to add a definition up here. So this just says again, just tells the linker to when it gets to here, Don't worry about it, because this is going to be defined further down the linkage process. All right, so AI orator, we have the AI name, and then we're also going to have this delay time handle here. So we'll be working with some timers as well. So I've got that struct. I'm going to bring in begin play, and this one I'm definitely going to be using end play for. So we already have begin play override. So I'm just going to bring in end play override. So I'm definitely going to be using this one because I'm using a timer, which is going to be used to pause, to work as a delay. I want to make sure that that timer gets cleared out if this object gets disposed of before this timer actually ticks. Then I'm just going to go through this. I need start new topic, delay conversation. Taking a look. Okay, so in addition, I'm going to bring in some functions. So again, we have start group conversation by IDs, start peer-to-peer conversation by IDs, and start new topic. So again, because I'm interacting, the way that the interaction, my interaction systems usually work is that I interact, and then that goes over to the thing that I'm interacting with, and then that will then determine how it wants to interact. And so that's how this is going to kick off. So start new group conversation by IDs. Again, we're going to have the topic and the starting point versus start peer-to-peer. It's the same idea, topic, starting point, but we're also going to add in the actor that we want to converse with. Start new topic, delay conversation. So because I'm going to be using a timer to act as a delay, I'm just going to put a little function in there. So all this is, and again, because it's going to be it's a delegate on a delay, I just need to add that function there. Let's see. I think that's all I need for now. So next up, underneath public, let's just bring in everything that we need for the orator. This is the interface, so that we're implementing the interface. All right, so again, this is everything. This is everything in the interface, and we're going to override it. It looks like it's not giving me green squiggly, so I'm just going to have to copy paste and fix it in the implementation. Okay, so let's get started. Let's just go ahead and just fix these real quick, and then I'll go ahead and bring everything else over. All right, so I'm going to go ahead and go over to the implementation. All right, so for this, in the implementation, all right, so for this one, since we don't have anything set up, I'm just going to go ahead and do it. So again, in the constructor, we need to go ahead and instantiate our components. So there it is, and I'm just going to go grab this. Oh, I've got an exit result and an orator, speaker, action. Missing two functions there. Let me go back and see if I can find them. Oh, yeah, missed these two. So I'm just going to go grab those, and I'm just going to put those there. So here we are, orator, exit result. So, and we'll see these in action when we start getting into the blueprints. And let's go ahead and just fix these green squigglies. Come back up top. So we have AI demo character. All right, so as far as includes, to fix the squigglies there, I'm just going to go ahead and bring this in. So there's the orator component, it's in line, and I'm also going to be referencing the Kismet library system again because it does the same thing as the players do to set that up. So demo character, so these are the two things that we're going to attach to. So we have on response action and speaker action. So we had speaker action, actually we had speaker leave action on the other one, where on AIs we have a response action. So this is if we exit out, right, and we need to either switch to a new, we're either switching to a new topic, or we're going to be exiting out to give someone a quest, or give someone a quest reward, or trade with them, or sell, or buy or sell something, right? That's where this would be coming out of right here, versus on speaker action. This is kind of just an action of, you know, when the speaker speaks. All right, so we have begin play. I'm just going to go ahead and bring end play and just modify this real quick. So for this one, I've got an end play, and this is we're actually going to be using this one because we have this time delay, and that time delay is going to be used on delay conversation, right? So again, this is something that we need to do because we're using this get time manager here, and we need to clear this timer out. If we don't clear it out on end play, and say we do a map switch while this thing is ticking, right? If this character is destroyed and this thing has not ticked yet, once it ticks on that map switch, the game will crash because it's referencing something that is no longer there. So that's very bad. So again, this is where we want to make sure we clean things up, properly clean things up when we destroy things at runtime. All right, so begin play. Do I have anything on begin play? Nope, so we'll just keep that. We've already defined end play. We've already defined our constructor. All right, start conversation by IDs. So I'm just going to go grab this real quick. So this is starting our group conversation by IDs. So this is the function that I'm going to be calling on interaction in the blueprint. So we call it. What we're going to do is we're going to pass in a topic ID and a starting point, and then in the orator we're going to pass in the starting point, and then we're going to tell it to join the conversation group. And then after that, we're going to go ahead and say get world timer, and we're going to use the time handle, the this pointer. This is the function that we're going to fire, and we're going to delay it by 0.5 of a second, and I'm going to set this to false. By setting it to false, this is a fire and forget. It'll fire it one time and then it'll clean itself up. If I set this to true, it means every 0.5 seconds it will continue to tick. So I'm going to use this as a delay timer versus a constant tick timer. All right, so that's that set up. And again, like I said, and I'm delaying this because we have this join conversation group. So what we want to do is we want to allow all of the AIs to form their conversation network first before we start that conversation. That way, no one misses out on the start of the conversation. All right, peer-to-peer, same idea. And I'm just going to, again, standard time. The only difference here is we're using join conversation versus group, in which we then pass in the target as well as the topic ID. And then we have start new topic. So this gets called when we want to change the topic of conversation. So when the AI is ready to do the topic switch, all it's going to do here is it's doing join conversation, and it's going to use the get new topic ID, which is on the AI orator. Feed that in, and again, delay everything until everyone's formed their new network for this new conversation. And in delay, it's pretty simple. We're just delaying the start of the conversation. So AI orator has start conversation, which kicks everything off. So we're just delaying this by 0.5 of a second before we fire it. All right, on orator exit results, I'm just going to keep that like, I'm just going to keep, we're not going to do anything on this. Instead, I'm just going to create an event binding in the blueprint. But if you wanted anything in C++, you could just bind it right there. And then on speak action, let's see, do I have anything there? Nope, same idea. I'm just going to bind to these in the blueprint. We're not going to do anything on ticks, so I'm just going to close this. And we don't need to worry about any setup player inputs because no player is going to be able to possess this AI. So now we just need the AIs for the interface. So I'm just going to bring those over. So the first one is going to be the character. So just like in the player, we've got the same interface. The only difference is we're going to be referencing the AI orator, and we're returning it by base class, not by, so this is the abstract class, so we're going to be returning the abstract, and we're not versus the concrete. Then next, I'm going to bring in join conversation. So this is our peer-to-peer. So again, very similar to the AI or to the player. The only thing is I don't need to worry about suspending and any interaction systems. But yeah, again, join conversation, topic, target. Here we are. Make sure first we're not in a conversation. Then we'll go ahead and has topic ID. Then if we have the interface and the interface is valid, we have a valid person that we can talk to, then we'll go ahead and add ourselves to the conversation. Otherwise, if they're not valid, then we're not going to do it. And then again, we just run the same recursion, and they'll do the same thing to us, but by then we're now blocking it. So this will block it before we call this. So when this comes back in, we're now blocked, so we don't run this a second time. All right. And then, so that's the peer-to-peer. So now we've just got the group chat. Gonna clean this up a little bit. Actually, I need to bring the whole thing over, don't I? All right. So again, very similar to how the player works. Again, in conversation has topic, add to conversation, and then what we'll do is we'll go ahead and set up our sphere overlaps, right? We'll run the debug. The only difference here is I'm using magenta. So again, very similar. And then again, a for loop, and then if we have, as long as we have something in here, we'll join the conversation and keep going. Otherwise, again, I'm doing a count. So we have this count plus plus. So I'm setting the counter here, count plus plus. If the counter is equal to 0, means we didn't find anyone to have a conversation with in this whole group. So I'm just going to go and end the conversation. We don't do this in peer-to-peer because in peer-to-peer, we're only checking on one person. But because we have to do the cast and then we have to iterate through the entire group, then it could be that some people in that group might not, where others maybe we do. So again, we just need to check that. All right, so that should do it for this. So I'm just going to go ahead and save that. All right, next up is going to be listen to orator begin. I'm just going to go ahead and copy this. And I'm going to bring this down here. As you can see, I've got a little note here, but we're not going to use it. But this would be, again, speaker comes in. So this is where you want everyone to turn and face the speaker. This is where you do the pivot. Or you could, again, or you could just bind this and do this in the blueprint too. But if you want to then just internalize it, you can do it on this one. And then we've got the orator response. So here, listen to orator. So again, this is begin. This is what we're listening to on the end. And again, we'll see this in action when we do the blueprints in the next videos. But again, respond. So it just takes the data and passes it into the orator, so it can do. It can go ahead and respond. If end conversation is called, just like with the player, we're going to remove from conversation. And if the interrupt is called, we're going to pass the state in, and then we're just going to set the interrupt state. If this entity is the speaking entity, then we're just going to go ahead and get its lines and pass it out so that the player can get access to our dialogue lines. And then we're also going to pass out our AI name as well, so we can use that for both the name of who's speaking and the lines, and we can match that up. All right, so that should do it for our AI. Let's do a quick little compile test to make sure that we haven't missed anything. So I'm going to move back to the editor. All right, good compile. All right, so I think this is a good place to stop this video. This is definitely going to be a long one. We've got a lot of code. But after all of this, we should be finished with the C++ now. And so in the next video, we're going to go ahead and create the widget for the player. So we'll create that dialog widget, and then we'll go ahead and into the player blueprint and start hooking things up. We'll create a simple little interaction system, and then we'll start hooking up some other additional things to help support the conversation on the player side. And then in part 5, we'll then go over and create the AI blueprint, and we'll then close that loop, and then we'll start creating some dialogue scripts so we can then show this thing working in all its glory. All right, so as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And if you have any questions, feel free to leave them in the comments below, and I'll see you again in the next video. Cheers, and have a great day.